Hello guys, thank you so much for joining this tutorial. I have written a little about the sources here in these slides. Among these, I really like Mr. Murphy's book. His view is a bit mathematical, but in my opinion, it is very suitable. Definitely, this course has many prerequisites. The first prerequisite is the course of analyzing and designing algorithms. The difference between the discussion of analysis and design of algorithms here and the preliminary discussions of analysis and design of algorithms is that here there is a lot of data. Another prerequisite is linear algebra. You need to be familiar with matrices and operations related to them. Although you don't need to be very familiar with these discussions, but the more you know about these mathematical foundations, the easier you will progress in the field of machine learning. Basic mathematical concepts such as differential and integral and the tangent planes are other prerequisites. And the last prerequisite is a preliminary familiarity with the discussion of possibilities. Be sure to have basic knowledge in these fields and then proceed to learn different fields of artificial intelligence and especially machine learning. In this training course, we will do several exercises in theoretical and programming fields. This is a general list of topics we are going to cover during this course. We will present an exercise of machine learning. A very important category is supervised learning, which has two parts, a regression and a classification. Another very important category is unsupervised learning, which in this discussion deals with clustering issues. Then we enter the topics related to reinforcement learning. Then we will enter into the topics of programming, and finally we will provide you with practical recommendations in using machine learning algorithms. The ultimate goal of this lesson is to this tutorial actually is to give you the knowledge that will help you to read and to learn any new algorithm that is needed when necessary. Because learning never ends in discussions related to artificial intelligence. If you consider all of the sciences in the world, machine learning is one of the top 3. So I recommend that you pay special attention to this course because this field is one of the most popular fields in the world. Machine learning is now used in all fields, and if you become an expert in this field, you can expect very high earnings. Therefore, no matter what I say about the importance of this field, we have said little. This training course is a good opportunity to learn the basics of this field. We are not going to discuss only theory here because this science is completely applied and functional. To see practical examples, you need to be familiar with the programming language, which according to the current trend in the world, the language used for us is the Python programming language. To work with a programming language, you don't need to learn all the details of that language, but your knowledge of that programming language will increase as you go through it. So don't worry about your little knowledge of Python programming language, because together we will acquire the necessary skills to use this language in the field of machine learning. So in this course, we will talk about the theories, and then we will mention the practical points. These tips usually have to be learned through experience and are not available in textbooks. I have brought you some quotes from famous people about machine learning and artificial intelligence. Let's go back to an old machine learning exercise that dates back to the dawn of artificial intelligence. Before presenting this exercise, people raised the idea that do computers have the ability to learn? Or can they only do what we tell them to do? The word artificial intelligence was introduced in 1956. One of the early applications of artificial intelligence in the computer world has been in the world of games, and a person named Samuel has started this process. You can search about it and read and see the useful information which is available in the internet. Due to time constraints, I cannot discuss these issues here. The idea was that if a computer can play games like checkers and chess, it can also do more complex and important tasks. Samuel tried to make the computer stronger in these games by repeating games and learning from mistakes and correcting them. In the beginning, the computer was losing to Samuel, but gradually it gets stronger and not only took away from Samuel himself, but also took away from all other human factors. This is the main goal of machine learning, to find a model that can progress, be trained, and in other words, be a learner without the need for explicit programming. We want our model to be self-learning. Because this self-learning is much easier for us humans, because an optimal and ideal model can be designed with a simple code of 30 to 40 lines. In some cases, for example, we make very good moves in driving and chess, but we cannot express it very precisely and clearly. Therefore, it is difficult to express in some cases. If there is no need to express everything accurately and quickly, many things will be easier for humans. Also, we want this model of ours to be able to get the optimal result in the face of any opponent and unknown problem. Years later, Mr. Tom presented this exercise. From now on, in this training course, you will use the word machine instead of computer. In this exercise, the performance measure is actually a score. In fact, if the machine can gradually learn how to increase this efficiency measure, performance measure, we say that it has the ability to learn. This exercise is classic, technical, and fairly precise. As another example, consider a spam detection service. You are all familiar with email and Gmail services. If you identify spam emails as you work with them, your machine learning model will gradually learn which emails you are not interested in and which emails you identify as spam. As you know, spam does not have a specific definition. An email may be considered spam to me, but not to you. So this definition is somewhat personal. This model gradually improves over time in distinguishing and separating spam from non-spam, which is actually the same task. Every time you read an email and send it to the inbox or spam, this experience model earns if it learns from this experience and gradually improves in performing this task. We say that this machine has the ability to learn. Here the efficiency measure, the performance measure is the percentage of correct detection of spam from non-spam. We have different types of machine learning methods. A very important question arises here. How does the machine know that its performance has improved? Depending on the answer to this question, we have three categories of methods for machine learning. When you drive, gradually you practice driving, you yourself realize that your driving has improved. How do you know? For example, in the beginning, you had an accident twice a week, and now you have an accident once a month. This can be a benchmark. Finally, you have a standard for yourself. The machine is the same. We need to help the machine to some extent so that it can understand whether its performance is improving or not. Machine learning methods actually came from here. If we give the correct answer to the machine, for example, let's collect 1,000 emails, and let's say 900 of them are normal emails and the remaining 100 are spams. That is, let's give the input and output to the machine. Every time the machine correctly distinguishes spam from non-spam, it will understand that it has improved. That is, every time it wants to know whether it has improved or not, it goes to those 1,000 emails and tests itself once. If the number of emails that are correctly categorized increases, it knows that it has improved. This method is called a supervised learning method. Another type is to not give the correct answer to the machine, but let's give it a signal. For example, tell the machine whether your work was good or bad, positive or negative. How positive or negative was it? For example, when driving, when facing an obstacle on the road, if the car brakes, we should encourage it, and if it does not brake, we should punish it. It is reinforcement learning that is most widely used in the field of robotics. The third way is to say nothing to the machine. We just give the machine a series of inputs. The machine itself figures out what to do with each input. First, we go to supervised learning. We define it a little more precisely and formally. There is an algorithm that we designed and provided to the machine. For example, in the example of spam detection, we have given the emails to the algorithm and told which ones are spam and which ones are not. Let's give an example to each member of the training group. Now we want to learn a function that given any input will figure out what the output is. We may not be able to implement this function exactly and find the correct output. We want to approximate it as well as possible. The good thing about this function is that it can be used for other inputs as well, even if it is not in the training set. Now the computer wants to learn this function. This is the definition of supervised learning. For example, in the example of spam detection, the output of this function is binary. In the house pricing example, each of these intersections is an input sample. In this example, we want to estimate the price of houses according to the size of the houses. What is the difference between these three examples? In the first example, the output set is binary. Either they are spam or they are not. In the computer, we specify everything with numbers, so they are 0 or 1. For example, it is the same for diagnosing whether or not a gland is cancerous. Here the output set is a finite and countable set, but in the house pricing estimation example, the output can be from 0 to infinity. That is, it is infinite. A discrete set containing an infinity of numbers. These numbers can be so close to each other that they cannot be deciphered by a computer. That is, if up to 16 decimal digits are equal, the computer is not able to distinguish between them. So, in fact, the computer considers this set continuously. So, based on whether the output set, the Y set, is continuous or discrete, we have two types of supervised learning problems. When faced with supervised learning problems, we may come to the conclusion that the desired function must be of first degree, second degree, or of higher degrees. If the output set is a continuous set, we call it a regression problem. So regression is a type of supervised learning where the set Y is continuous. We want to predict values that are continuous. Another example is temperature forecasting. But we call problems where the output set contains a finite number of discrete values classification problems, like diagnosing whether the glands are benign or malignant. In the next video, we will explain regression problems and check the relevant algorithms. But is only the size of the gland enough to determine whether tumors are benign or malignant? Not 100%, but the type, shape, and uniformity of the cells is also important. For example, the age of the patient is also important. That is, in problems like these, our inputs may include two numbers. One is the age of the patient and the other is the size of the tumor. Both of these values should be taken into account to classify tumors. That is, we have to consider a border to be able to do this classification. Now, suppose we are given a new data including the age of the patient and the size of the tumor. We can do this classification. We have considered the two-dimensional problem here. Of course, we can increase the dimensions and parameters, and in this case, the shapes become three-dimensional and four-dimensional, and etc. In this case, the work becomes visually difficult. For this reason, we try to discuss issues on a one-dimensional, two-dimensional, or finally three-dimensional level. Here we have assumed the problem to be simple because we have assumed that the number of data is low. But if the number of samples and data is, for example, 20 billion, algorithms and computer power are needed. The second point is the dimension. There are millions of features in the real world. That is, the number of axes is millions. For this reason, calculations become complicated and difficult, and very good algorithms and very high power of today's computers are needed. In the next session, we will define the definition of unsupervised learning. Have a nice day.